a retail manager trying to stock the exact right amount of inventory, or a hospital administrator calculating how many beds will be needed next Tuesday. They are both chasing the same thing: absolute certainty. To achieve that dream of a guaranteed outcome, organizations turn to predictive analytics. They take piles of historical data and feed it into models, hoping to find a clear path forward. The primary statistical engine they use to identify those relationships within the data is called regression analysis. But Dr. K often reminds us that a predictive model can absolutely sound much smarter than it actually is. It's easy to look at a statistical estimate and mistake it for a guarantee. Trusting an equation blindly, without understanding the assumptions it was built on, creates a false sense of security. Prediction is useful, but as we're about to see, prediction is never perfect. Regression is a form of supervised learning. This just means the business has a specific historical outcome, like last year's revenue, and wants to train a model to predict it. The first step is simple visualization. By plotting these historical records, we can step back and observe the overarching trend before we worry about the math. Once the shape is clear, we calculate the best fit line. It slices through the center of the historical data. The line's entire purpose is to position itself to minimize the overall distance to every single historical dot. It's a mathematical estimation designed to reduce prediction error based on what happened in the past. It isn't magic, it's a calculation. The first major trap is the data itself. A predictive model inherits every weakness, bias, and flaw hidden in the raw records you provide. If a staffing model is built on flawed historical schedules, the software will confidently calculate mathematical nonsense. As Dr. K says, Excel will calculate anything you tell it to, whether the assumptions make sense or not. Then there is the second, more seductive trap that occurs during the training phase. We call it overfitting. Look at this jagged path. Instead of finding the trend, it memorized the historical data perfectly. The failure happens when tested against brand new data. Because it only knows the past, it completely misses the new reality. A model that looks mathematically perfect on historical data creates a dangerous false confidence that shatters the moment conditions change. This is different from unsupervised learning or data mining, where algorithms sift through massive datasets to find hidden patterns without a specific target in mind. But whether you're mining or modeling, you have to avoid the causation trap, assuming that because two variables move together, one must have caused the other. Ice cream sales and shark attacks both spike at the same time of year. A model will find that correlation instantly, but buying a vanilla cone obviously doesn't summon a shark. Algorithms are excellent at finding mathematical correlations, but human logic is required to determine if there is a true business reason behind the numbers. In any real-world business environment, prediction error, what we call residuals, is unavoidable. Regression doesn't eliminate uncertainty, it just gives us a framework to measure it. It's a reminder that prediction is not the same thing as certainty. No matter how statistically strong a model looks, it's practically useless if its outputs defy logical business sense on the ground. Ultimately, analytics should improve judgment, not replace it. These models are sophisticated compasses meant to support a manager's intuition, not override it. Regression identifies the mathematical links between specific variables, but it typically looks at the world in a static snapshot. But businesses don't stay still. They move through time, constantly affected by changing trends, seasonality, and volatile market shifts. The question for a leader then becomes, how do we predict the way these patterns will evolve over weeks, months, or years? It's time to leave the static best fit line behind and step into the dynamic world of forecasting and time series analytics. Say